Section 2.5, we are going to see how do we solve linear systems, right? So firstly, what does a linear system look like? We start with a linear system containing two equations, and later we will see linear systems with three equations in it. And we start with the basic. What does a linear system containing two equations look like? What does the linear mean here? All right, so a linear system with two equations look like this. Well, in the book, you don't really have this symbol. That's my own symbol. I like to use this symbol to group two equations together. Then you can see they are a system, right? In the book, you don't have that. Just let you know. So the first equation, a sub 1x plus b sub 1y equals c sub 1. And the second equation is a sub 2x plus b sub 2y equals c sub 2. So the first equation, I also like to label this is first equation, this is second equation. This is a system of two equations. And both equations, if you look at it closer, they are the standard form. They are in the standard form of a linear equation in two variables. They represent straight lines. So make it simple. You do not have to worry about what is A1, B1, C1 here. What is A2, B2? Do not worry about that. It's just the way to show a linear system with two equations look like. And the more, make it simple for us. The first equation is the equation or an equation of a straight line. That's first equation. Second equation is also an equation of a straight line. If you see a system like that, that system is a linear system. The key word here is linear. Linear system is a system with linear equations in it only. All right. So basically, if you see any system with two equations and both equations represent straight lines in a rectangular coordinate system, then that is a linear system. All right. And graphically speaking, we have three types of linear systems. I'm going to show you the three graphs in second part of this topic. I'm going to draw three rectangular coordinate system. And I'm going to show you the three cases. Case 1, this is a case 2, this is a case 3. Since the two equations in the system represent straight lines, then we have three cases for the solutions of the system. So the first case, the two straight lines do not overlapping or do not parallel, they cross. So let me use the red color to represent the first line, okay? For example, the first straight line, the first equation corresponding will represent this straight line. And another, I'm going to use this blue, bright blue color, right? So this is the straight line represented by the second equation. As you can see, those two straight lines do not have the same slope, right? They are not parallel. They cross. So they cross at one point here, right? So this system, when you have a system, linear system, the two straight lines in the system cross at one point, then the system has one solution. And the one solution, the unique solution, is an ordered pair. The focus of today actually is to solve this type of system. The linear system have two straight lines in it, and they cross at one point. And our focus today is to find that one solution, the coordinates of that point. So that's the first case, when the two straight lines cross at one point. Second case is possible. The two equations in a system, they represent two straight lines with the same slopes. And we know if two straight lines have the same slope, then they are parallel. We understand what is parallel, right? So let me graph the case 2. When the two lines are parallel, for example, this is the first equation corresponding to this red straight line. And the second equation in the system correspond to this straight line in blue. And those two straight lines are parallel. They have the same slopes. They are two different straight lines. They are not overlapping, right? So in this case, the system has no solution. Why they do not have a solution? Let me explain. In order for an ordered pair to be a solution of the system, that ordered pair has to satisfy both equations. In other words, graphically speaking, in order to have a solution, in order for the system to have a solution, the two straight lines must cross. They have a common point, like the case 1. In case 1, this point, this ordered pair satisfy the first equation, also satisfy the second equation, because the point is on the red straight line, also on the blue straight line. So that's the only solution. In order for an ordered pair to be a solution of a system, that pair has to satisfy both equations. Graphically speaking, the point represented by the ordered pair has to be on both straight lines. Okay, if the system has a solution, that point has to be on both straight lines. And there's no such a point on both straight lines in this case 2, because the two straight lines are parallel, right? They do not have any common point. So in this case, the system has no solution. Yeah, we're gonna look at it again later when we have a specific problem. And the third case is possible that the two equations in the system, they are the same equation. Maybe they look a little bit different, but if you modify the equation, and you'll see the two equations in the system are identical. In that case, the two straight lines, say this one is the blue line, and this one is the red line. In this case, the two straight lines overlapping or coinciding, then the system has infinitely many solutions. All the points on the straight line, the two straight lines are overlapping, right? And there are infinite many points on the line, on the two lines. Actually, it's the same line. Those points are all the solutions of the system because they satisfy both. They are the same equation anyway. So case 3, when the two straight lines are overlapping or coinciding, it has infinitely many solutions. All the points on the straight line, they are solutions. All right, so we also need to understand what it means when we say a system is consistent, inconsistent, dependent, independent. Before that, I want to ask, are the 3 cases clear? Do you have an idea about what is a linear system? We start with a simple case of a linear system. The system only has 2 equations in it, and the 2 equations both represent straight lines. Then we have 3 different cases. When the 2 straight lines cross at one point, then the system has one solution only, and the intersection of the 2 lines is the solution. When the 2 straight lines are parallel, the system has no solution because there's no such a point on both the straight lines. There's no such ordered pair would satisfy both equations. Or sometimes the two equations in the system overlapping or coinciding. In that case, the system has infinitely many solutions. I want to know, give me some response. Are the three cases clear?
Yes, ma'am.
Yes.
Okay, very good. Then let's talk about what is consistent, inconsistent, dependent, independent. All right. I need a more space here. I'm gonna put a page break here. All right, very good. So let me explain what is a system. What is a consistent system? A system linear system, okay? A linear system is consistent if the system has at least one solution. It could have more, but at least has one. Yeah, basically, if the system has a solution, at least a solution, then it is a consistent. So it's called a consistent. A linear system is inconsistent if it has no solution. Like our case 2, right? No solution. So that's when we call inconsistent. If a system has exactly one solution, then the system is independent. And that's what a system is independent mean. Independent. If a system has infinitely many solutions, then the system is dependent. I'm gonna start a new line, is dependent. Yeah, that's the definition. It's just just 4 definitions. When do we say a system is consistent? If it has solutions. It doesn't matter how many solutions. It's called consistent. A linear system is inconsistent if the system has no solution. It cannot make sense, right? Yeah, inconsistent means there's contradiction in it. There's something wrong that prevent the equation, the system has solutions. So inconsistent means no solution. And if a consistent system means it has at least one solution, right? Only has exactly one solution. If it has a unique solution, like case 1, there's only one solution. If the system only has one solution, we say the system independent. But if the system has infinitely many solutions, like case 3, right? When the two straight lines are overlapping or coinciding, infinitely many solutions, then the system is called dependent. Okay, I believe once you understand the definitions, that's how they are defined. We have to follow the meaning. Then we know how to determine if a system consistent or inconsistent, dependent or independent. Let's look at case 1. Let's look at case 1. Case 1 has a solution, right? So consistent. It has exactly one solution, so independent. Let's look at case 2. Case 2 has no solution, so inconsistent. And when the system is inconsistent, we do not talk about dependent or independent. Dependent or independent is about a consistent system. Inconsistent system doesn't even have a solution, so we do not need to discuss its dependence or independence, right? It's just inconsistent. It has no solution. Case 3 has a solution, so consistent. And it has many, infinitely many solutions, so dependent. Yeah, just some definition that can help us to categorize linear systems with two equations, just like that. You do need to know those because your assignments in Lumen mention those concepts. All right, next. So as I mentioned earlier, today our focus is to solve a linear system, mainly in case 1, right? Well, if it has no solution in case 2, then we don't have to solve because no solution. If it happened to be case 3, then we don't need to solve it either because all the solutions are the points on the straight line. We can just say infinitely many solutions. Mainly, our focus is to solve a system in case 1, when the two straight lines do not have the same slope, they cross at one point. We want to find that one point. Use algebraic method. Okay, so which two algebraic method? We're going to learn 2 methods. Okay, we're going to learn 2 methods. 2 methods to solve a linear system. The first method is called the elimination method. The second method is called the addition method. Those 2 methods apply to any type of system, not just a system linear with 2 equations. When a system has 3 equations or nonlinear, those 2 strategies, those 2 methods still work. Okay, let's look at a specific problem. This system, oh, actually our book does do this. Yeah, they do have this. Some books don't even have that. That's good. I'm going to label the first equation number 1, second equation number 2, all right? First equation is x equals -5y minus 5. Second equation is 5x plus 25y equals -25. Okay, so first equation represents a straight line. I don't know if you see it. It has both 2 variables, x, y, and the exponent on the shoulder of x is 1. It means first power. You don't have a square or -1 power or square root, right? So that makes the first equation linear. It represents a straight line. Same with the second equation, also represent a straight line. And we want to find, when I quickly look at it, I can see the first equation has a slope of -1/5. Second equation has, oh, hold on a second. You know, I think they might have the same slopes. So this is what we are going to do, okay? I'm going to simplify the first equation, rewrite the first equation in a sloping subgroup form. How about that? X equals -5y minus 5. All right, so I like to separate the equation in the middle. And I'm going to use my side and sine technique to reorganize the equation. We have 3 terms in the equation, x, -5y, -5. I'm going to move -5y to the left side, and it becomes +5y. When we move a term from one side to the other side, we can do that, but at the same time, we need to switch the sign. So the -5y is negative on the right, now is positive on the left. Similarly, I'm going to move x to the right, and I have -x, right? X is positive on the left side, now it's on the right side, it's become negative. I'm going to bring down -5. And then I'm going to divide all the 3 parts by 5, divide by 5, divide the coefficient of x by 5. Coefficient of x was -1. now it's -1/5, and then divide by 5. Cancel, cancel. We have a y equals -1/5 times x minus 1. So that's the first equation. The first equation after simplify is y equals -1/5x minus 1. That's the first equation. Second equation, let's simplify. 5x plus 25y equals -25. Right? 3 terms as well. I'm going to keep 25y on the left side and move 5x over. 5x now is on the left side, to the left of the pink line, right? And I want to move it to the right side. So move it and change the sign, -5x, and bring down -25, right? So this is my technique. Try to see it. If you don't like this method, you can just -5x from each side, and you would have the same thing. It's just my method here. Side and sign is faster. And then divide everything by 25. Divide 25, divide 25, divide 25. Cancel, cancel. We have y equals -5/25, 1/5 times x, and minus 1. Hold on, look at this here. So the second equation, y equals -1/5x minus 1. What happened? Those two equations in the system are identical. They do look different in the original form, right? But be careful, we have 3 cases. We should, before trying to solve it, we should spend some time to determine which case this system belong to, right? Turns out, which case, guys? The 2 equations are identical. The 2 equations represent the same straight lines. What case? We have 3 cases.
The third case.
Perfect, yeah. In that case, the system has infinitely many solutions, right? All the points on the straight line, if we graph it, it's gonna be a straight line going down because the slope is negative, right? All the points on the straight line are solutions. Let's read this part. Enter your answers as integers or as reduced fractions in the form a/b. If there is no solution, type does not exist in each blank. If there are an infinite number of solutions, specify their form in the blanks in terms of y. Okay, so this is how do you do it, all right? So you are going to, since this system has infinitely many solutions, specify their form in the blanks in terms of y. Okay, this is what you do. In terms of y. So answer, this is y, right? The second component is y. And the first component, we can just do x. And you know what? X is 95y minus 5. So in terms of y. I actually believe in terms of x is better, but it asks to write the solutions in terms of y. And that is the solutions, okay? In the parentheses, we have the 2 components for the point that represent a solution of the system. The second component is always y. The first component is always x. And then remember, x equals what? X equals 95y minus 5, very convenient. So just like that, all right? I don't remember which question this is. So look at your Lumen to try this format. I think this would work. If not, let me know. Is this clear? So when we solve a system with 2 equations representing 2 straight lines, do not rush. Do not rush yet to just solve, right? Apply the elimination method or addition method. Do not rush yet. Spend some time to look at their slopes to see if they are, if the system case 2 or case 3, right? If it's case 2, no solution. If it's case 3, infinitely many solutions. If it's case 1, then you apply elimination method or addition method to find the one solution. Okay. Next, this one. Okay, so as I said, spend some time to look at the slope, right? Yeah, I don't know if you remember in previous sections, I told you a formula. If the equation is in the standard form, then we can quickly find the slope by using this formula. So I can quickly, you don't have to, you can rewrite the equation in the slope intercept form and then identify the slopes. I can use my trick to quickly identify the first equation. No, this one doesn't have that. So I like to use that symbol. So the first equation slope is 5/2, negative 5/2 actually, negative 5/2. The second equation slope is 6. Okay, they have no same slope. They do not have the same slopes. For that reason, they're gonna have one solution, all right? And we're gonna find that one solution. We're going to find that one solution. How do we find that one solution? This problem, I'm gonna use both methods. It says use addition method. I'm gonna use 2 different methods, right? The first method, method 1, elimination method. In order to apply elimination method, we firstly have to look at the 2 equations, find the one equation that is easier for us to write one variable in terms of the other. And I look at the 2 equations. I'm gonna start with equation 2. Equation 2 is negative 6x plus y equals negative 8. And I can quickly to write y in terms of x. Y equals positive 6x minus 8. Okay, explain my strategy, my technique. Very useful, very convenient. What I have done to this equation is I moved the orange term from left to the right. It was negative on the left, now become positive on the right. That's all I did. After this, I have variable y in terms of x, right? We use x actually represent the y. So I'm going to label this equation number 3, all right? Number 3. Elimination method simply means we have 2 variables, too many. We want to eliminate one variable. And then leave one variable and solve that left variable and then go back to solve another variable. So elimination method means just get rid of one variable. 2 unknowns, too many, get rid of one. So we want to get rid of y because it's easy to write y in terms of x, okay? And then what do we do now? We are going to, sometimes they call this a substitution method. The elimination method, substitution method. Maybe it's called a substitution method. Yeah, it's called a substitution method. Yeah, not elimination method, substitution method. Some books, they use different names. Yeah, I think the substitution method. So now we're going to substitute. We are going to substitute y in equation 1. We did equation 2 already. So now we're going to handle equation 1. Substitute y in equation 1 with, no, 4. 4. Okay, actually, correct English grammar is substitute 6x minus 8 for y in equation 1. Okay, that's the correct grammar. Basically, I want to say this is equation 1, all right? This is equation 1. Negative 5x minus 2y equals negative 18. This equation 1, has a variable x and has a variable y. We don't want that. We want to get rid of variable y. So we want to replace the variable y with 6x minus 8. And that in English also called a substitute, 6x minus 8 for y, right? Okay, let me show you how to do that. This is equation 1. We copy everything. Copy -5, copy x, copy -2. But when you see y, you do not copy y. Instead, you are going to replace y with 6x minus 8. We are able to do that because in equation 3, as you can see, it shows y and 6x minus 8 is the same thing, right? Y equals 6x minus 8. So we can use 6x minus 8 to substitute for y. On the right side, we copy everything, right? So when we substitute, we just copy everything until we encounter variable y. Instead of copy y, we use the substitution to replace y. The substitution is an expression in x. After this, look at this equation, no y. Okay, no y, so y is eliminated. Okay, then there's no y, there's only x. Let's solve x. -5x, distribute. -2 times 6x, -12x. -2 times -6, positive 16. How important foundation 2 is. If you struggle with this, watch the video I posted. So this is distributive property, okay? -2 times 6x, -12x. -2 times -8, positive 16. On the right side, -18. Simplify the left side. -5x, -12x, -17x plus 16 equals -18, right? And you can minus 16 from each side. Cancel, cancel. -17x equals -18, -16 is -34. Yeah, -34. And then divide each side by -17. Divide by -17. Cancel, cancel. We have x equals +2. Not done yet, guys. Yeah, you might attempt to stop here, but no, we are not done yet. Because the solution of the system, we know there's one solution, right? The solution of the system is going to have two components. It's an ordered pair. Now we only got the first component. We have to find the second component as well. We need to find the corresponding y value. So after we have x equals 2, plug x equals 2 into equation 3. All right, this is equation 3. Equation 3. So we have y equals, equation 3 is y equals 6x minus 8. And we plug in x equals 2. 6 times 2 minus 8. 6 times 2 is 12. 12 minus 8 is 4. Okay, now we are done. Conclude. The system has one solution, and the one solution has two components, right? Because it is an ordered pair. Graphically represent a point in the rectangular coordinate system, two-dimensional system. So x equals 2, y equals 4. And now we're done, all right? Now we're done. One solution. The one solution is 2, 4. When you take a test, you should always double check your answer. You can plug in x equals 2, y equals 4 to both equations. Make sure this ordered pair does satisfy both equations. Then your answer definitely is correct. So the first method I use a substitution method, okay? Sorry about that. Substitution method, I think the name. Substitution method. And second method, I'm gonna use the addition method. I'm gonna rewrite the two equations again here. -5x minus 2y equals -18. That's equation 1. Equation 2, -6x plus y equals -8. Yeah, double check the copy is correct. All right, so let me show you how to use addition method to eliminate one of the two variables. I look at variable x. The coefficient of x is -5 in equation 1, is -6 in equation 2. Not very convenient. But when I look at the variable y, in equation 1, coefficient of y is -2. In equation 2, coefficient of y is 1. A lot simpler. So for that reason, because the coefficients of y, variable y, in the two equations are a lot simpler, I decide to eliminate the y by using the addition method. How do we do that? How do we do that? This is what we're going to do, okay? Copy equation 1. Copy equation 1. And then do something to equation 2. What's the thing that we do to equation 2? We're going to multiply equation 2 by +2. Equation 2 has 3 terms in it, right? Yeah, I can write it here. Equation 2 has 3 terms in it. -6x plus y equals -8. I'm going to multiply all the 3 terms by 2. Multiply equation 2 by 2. So -6x, after we multiply by 2, we got a -12x, right? -12x. And y multiplied by 2, we have 2y. On the right side, -8 multiplied by 2 is -16. So that's what I meant when I say multiply equation 2 by 2. All the terms in the equation must be doubled. So we have equation 3 that is doubled equation 2. So we have -12x plus 2y plus -16. Why do I do that? Because after I do this, look at the variable y in equation 1 and equation 3. Look at variable y. Look at the coefficients of variable y in equation 1 and equation 2. Equation 3, sorry, equation 3. They are what? They are opposites. Yeah, that's the idea of applying addition method. The essence, the key of applying addition method is you manage to change the coefficients of one of the variables, in this case, variable y, as opposites. So after the modification, in equation 1, coefficient of y is -2. In equation 3, coefficient of y is +2. We like that because we are going to add equation 1 and equation 3 together now. Addition method, right? Addition method. Now we are going to add. We are going to add equation 1 and equation 3 together. -5x, -12x does not give us -17x, right? -5x, -12x give us -17x. And -2y, +2y, they add up to 0 because they are opposites. They cancel. So no y, y is eliminated. Equals -18, -16, -34. And then divide each side by -17. We have x equals 2. And then plug x equals 2 back into maybe equation 2, because equation 2 has smaller numbers. And we have -6 times 2 plus y equals -8. -12 plus y equals -8 plus 12 plus 12. We have y equals 4. Same thing, right? We get the same answer. Yeah, I just want to show you how do the two methods work in solving a system. Substitution method is to pick one equation and write one variable in terms of the other. So in our problem, we write y in terms of x. So later, we are going to substitute 6x minus 8 for y in equation 1. And that's how do we get rid of variable y. Get rid of variable y. There's only one variable x left, then we can solve for x quickly, right? And then you put it back and you solve the corresponding y. The key of applying addition method is to look at the two equations look at the coefficients of the two variables. Find the one variable whose coefficients are easier to manage. In this case, variable y. Very easily, we can just multiply equation 2 by 2, and we can make variable y have opposite coefficients in both equations. Since the two coefficients are opposite, if we add the two equations together, add equation 1 and equation 3 together, variable y will be eliminated. So the key of both addition method and the substitution method is eliminating one variable of the two variables. Is that understandable, guys?
Yes, I understand it.
Okay, perfect. Yeah, very good. So through this problem, we understood the both methods, right? Or you can just see them as two strategies to solve system. Okay, so what if a system has three equations like this one? Then graphically would be different, okay? Because the system has three equations, has three variables. So a rectangular coordinate system, a two-dimensional space is not enough. You're gonna look at, basically is, if we really wanna think about the geometric significance, we would have to look at a three-dimensional space, X, Y, Z. And we don't do that. It's more complicated. So just know those three linear equations, they are straight lines in a three-dimensional space. In a three-dimensional space, not on a plane anymore. More complicated geometric wise. But we can use algebraic method to solve the system, right? We can try substitution method or addition method or a combination of the two strategies, right? The key is eliminating. Now we have three variables. We try to get rid of one. Then we would have two left. And then we manage to get rid of another one. And then we will have one variable left. When we have one variable left, we can quickly solve the value for that variable and then go back to find the values for the other two variables, all right? So you don't have to, I need to change this to substitution. This is substitution. They both are elimination purpose oriented substitution method. Okay, let's look at our system. One, two, three. Yeah, before we do anything, just look at the equation. Yeah, do not rush yet. You're gonna figure out a way to do it, right? It's like when you drive out somewhere you are not familiar with, do not just drive. Yeah, look at the map and figure out an outlet. Find a strategy to get started. When I look at the three equations, I'm looking at the three variables and their coefficients. I think what I want to do is I can get rid of z first. I can get rid of x easily as well. So the way you do it is could be you can have multiple different ways to process the same problem. Really depends on your preference. How about let's get rid of z. Yeah, let's get rid of z. So how do we get rid of z? After I observe their coefficients, I'm gonna do this, okay? I'm going to multiply equation 1 by 5 and then add it on top of equation 2. Why? Because look at here. Look at here. We have 95z. Here we have z. If we can make this z as 5z, then we add the two equations together, z will be eliminated, right? So that's the idea. Okay, let's do that. Let's do that. Equation 1, -2x minus y plus z equals negative 17. Multiply by 5. So everything multiplied by 5. Negative 2 multiplied by 5, negative 10. Negative 1 multiplied by 5, negative 5y. Z multiplied by 5, 5z. Negative 17 multiplied by 5, 17, 5. 85? Yeah, 85. Negative 85. Yeah, I noticed since I have to calculate in English, my calculations slow down. I used to be able to calculate very quickly in Chinese because when you calculate, you have to think, right? You are thinking in Chinese. But now you have to think in English. I feel like I do kind of slow now. Is 17 times 5 equals 85? I think so. Yeah, and this is 5, 5, 5. Okay, very good. So this part, let me use the color scheme. This equation, I got this equation by multiplying equation 1 by 5, all right? And then I'm going to add it on top of equation 2. Equation 2 is x negative 6y minus 5z equals negative 13. This equation 2, okay? Yeah, let's add them together. Let's add those two together. Let's add those two together. All right? Negative 10x. Yeah, let me use the scheme, color scheme. We are adding blue and yellow together, guys. We are adding blue and yellow together. So negative 10x, x, negative 9x. Negative 5y, negative 6y, negative 11y. 5z minus 5z, cancel. That's what we want, right? Cancel, we cancel. Equals negative 85, negative 13, so negative 98. If I calculate anything wrong, please let me know. Negative 98. Okay, so I'm going to put that equation here. Negative 9x minus 11y equals negative 98. Yeah, and you can actually, you know what? We can simplify this equation. This equation has 3 terms. All the 3 terms are negative. Why don't we just get rid of the negative sign from all the 3 terms? So we have 9x plus 11y equals positive 98. So positive, okay? Positive. I'm going to label this equation as 4. Equation 4. 9x plus 11y equals 98. Let me double check just in case I made some mistake. 5, negative 9. 5, negative 11. 5, Jesus. 85, 13, 98. Okay, seems right. So now we have equation 4 only containing 2 variables, x and y, right? Same idea. I'm going to continue doing the same thing, but this time I'm going to handle equation 1 and equation 3. I'm going to multiply equation 1. Oh, hold on. I need more space. Okay, now we have the whole page. Now I'm going to do equation 1 times positive 3 and add it on top of equation 3. All right, so that's the idea. Let me write equation 1. Yeah, this is equation 1. Equation 1 is negative 2x minus y plus z equals negative 17. So this is equation 1. We are going to multiply this equation by 3. So everything multiplied by 3. Negative 6x, negative 3y plus 3z equals 17 times 3. 51, negative 51. Right? So yeah, that's gonna be the green equation, all right? So I got a green equation by multiplying equation 1 by 3. Let me double check. Negative 2 becomes negative 6, negative 1 becomes negative 3. 1z becomes 3z, negative 17 becomes negative 51. Okay, that's correct. And then I'm gonna put equation 3 underneath. Equation 3 is negative 3x positive 5y minus 3z equals 5. This is equation 3. I'm gonna color it as pink. All right, negative 3x plus 5y minus 3z equals 5. Okay, now I'm gonna add the two equations together. Negative 6x, I'm adding the green one and the pink one. I'm adding green one and pink one. Negative 6x, negative 3x, negative 9x. Negative 3y, positive 5y, positive 2y. 3z cancel negative 3z, right? That's what we planned to achieve. Right side, negative 51 plus 5, negative 46. 11 minus 5, 6. 46, correct. All right, so that is another equation. I'm going to put it here. Negative 9x plus 2y equals negative 46. I'm going to label this equation as 5. After we apply 2 times addition methods, we derive 2 equations without z. Yeah, we successfully eliminated z. Now look at the system on the top left, the number 4, number 5. We are going to keep doing the same thing to get rid of another variable. Yeah, we already successfully get rid of z. Now we want to get rid of what? Look at the 4 and the 5. We want to get rid of x. Isn't that already ready to be get rid of? In equation 4, 9x. In equation 5, negative 9x. Okay, is ready for us to adding together, right? Number 4, equation 4, add equation 5. 9x, negative 9x cancel. 11y, 2y, 13y equals 98 minus 46, 52. 8 minus 6 is 2, 9 minus 4 is 5, okay? So divide by 13, divide by 13, y equals 4. Yes, okay, y equals 4. Ta-da, y value is found. Then let's find what is x. Plug y equals 4 into either 4 or 5. I'm gonna do 5 only because 5 is a number. So negative 9x plus 2y equals negative 46. Negative 9x. Y is 4, 2y is 8. Negative 9x, so bring the 8 to the right side is negative 54. 14. Yeah, 54. Okay, divide by negative 9. You can slow down or leave this part later. The thing we learned from the class is the method. X equals positive 6. Okay, we now get a y, we now get x. We're gonna find out what is z, right? We are going to plug y equals 4 and x equals 6 into one of the 3 equations in the original system. Equation 1 or equation 2 or equation 3. Which one has smaller coefficients? I'm gonna do 1. I'm gonna do 1, okay? Into 1, which is negative 2x minus y plus z equals negative 17. Let's plug in y equals 4, x equals 6 there. X equals 6, so negative 2 times 6 is negative 12. Y is 4, so minus 4 plus z equals negative 17. Negative 12, negative 4, negative 16 plus z equals negative 17. You add 16 to each side. Z equals negative 1. Okay, here we go. We found our solutions. X is 6, y is 4, z is negative 1. So as a tripler, not a pair anymore, because it has 3 components. The solution is 6, 4, negative 1. If you got the time, we should plug in back to see if x equals 6, y equals 4, z equals -1 satisfy all the 3 equations, okay? 6, 4, -1. 6, 4, -1. Let me just quickly get that done. -12 minus 4, -16 plus -16 minus 1 is okay. Equation 1 is satisfied. Equation 2, -6 times 4, -24. 24 plus 6, -18. -18 plus 5, -13. Correct. That equation 2 is satisfied. Equation 3, x is 6, -3, -18. -18 plus 22, positive 2, plus 3, because -3 times -1 is positive 3. 2 plus 3 is 5. Okay. I am assure you this is the correct answer. We got the solution, all right? So this is how we handle it when the system has 3 linear equations. It's a lot of work. When you get to a higher level of mathematics, you need to sometimes have to come outside your comfortable zone. Maybe in previous classes, those questions doesn't require so many steps. Even some questions just one step done. That's why I did have students, they just wanna tell me what's the answer. I cannot tell you the answer. I can tell you the process. It takes the process the important thing, not the final answer. It takes a lot of steps to get it done. Okay, the last topic of this section is the application of system. All right, application of system. That might take a little bit. We don't have time to cover this problem, so I'm going to skip this one. Application, we have 20 minutes. Maybe we can get this problem done. All right. Application of linear systems. The admission fee at an amusement park is $2.50 for children, $7 for adults. On a certain day, 290 people entered the park, and the admission fees collected totaled $1,220. How many children and how many adults were admitted? Okay. We are looking for the number of children. We are looking for the number of adults as well. All right. So how about let's use X to represent the number of children who went to the park, and let Y to represent the number of adults who went to the park. Since we have 2 variables now, we are going to set up 2 equations. Let's read the question and find information that we can use to set up the equations. Firstly, this information, 290 people, okay? 290 people entered the park. People, either adults or children, right? I would say, yeah. Assume, yeah, we don't consider babies or babies including belong to children. So 290 people in total entered the park. And what does that mean? Does this information give us the first equation, x plus y equals 290? Okay, any responses? Have not heard you for a while.
That sounds about right.
Okay, very good, thank you. So we have one equation already. Let's look at the problem and find another equation. We're gonna use the price of the ticket, right? Children, $2.50. Now, one children, you collect $2.50. 2 children, you collect 2 times that much money, right? 3 children times 3. Now we have 4 children, you times 4. Now we have X children. We have X children. So you multiply the price of the children ticket by X. So 2.50. I'll just do 2.5, okay? 2.5x. For adults, one adult, you collect $7. 2 adults, you times 2. 3 adults times 3. 4 adults times 4. 5 adults times 5. Now you have a Y adults. So times y. So $7 times y. That's the total money you collected, right? And it's given $1,220. That's equation 2. Do you agree, guys?
Yes.
Awesome. So for this problem, I would say, of course, you can use addition method. I would say substitution method probably pretty convenient because of the equation 1. I'm going to use the substitution method here. From equation 1, I can quickly write y in terms of x. Y equals 290 minus x. Yeah, I move this term x from left side to the right. Positive become negative. You can get it done by subtract x from each side, right? Yeah, you get the same thing. So now I have equation 3. This is equation 3. I'm going to highlight the equation 3 as yellow, blue. Equation 3 is blue, okay? I'm going to substitute. Because of equation 3, I'm going to substitute 290 minus x for y in equation 2. Okay, let me copy equation 2. Equation 2, 2.5x plus 7y equals 1220. I'm going to substitute 290 minus x for y. Okay, that means we are going to get rid of y. Yeah, get rid of y. Only have x. So copy everything that is not y. 2.5x plus 7, copy everything. But when we see y, do not copy it. Instead, copy 290 minus x. They are same anyway, right? Look at the equation 3. And equals 1220. And then you solve this equation, you get the value for x. Once you get the value for x, you go back to equation 3, find the value for y, and you will have your answer. And we are not going to solve here, but the idea, the most important thing is to model the situation, right? What is model the situation? Means we found the system that could represent the situation and give us a way that we could solve for x and y. All right, the solving part, I'll leave you to figure it out. And next one, this way, then we can maybe look at more application problems. This problem, Canon invests $7,600 in 2 different accounts. The first account paid 14%. The second account paid 2% in interest. At the end of the first year, he had earned $812 in interest. How much was in each account? You actually have a similar, probably exactly the same problem in Foundation 2. It's just in Foundation 2, you're applying linear equation to solve the problem. Here we are applying a system, linear system to solve the problem. 2 accounts, right? I'm gonna use 2 boxes to represent it. 2 accounts with different interest rate. One account has interest rate 14%. I'm gonna put the interest rate on top of the box. One pays 14%, the other pays 2%. Normally, when the interest rate is higher, that means it is risky. When the interest rate is lower, that means it's safer. So when people invest, they wanna, what is that called? Yeah, you don't put you do not put all your eggs in one basket. So 2 baskets here. So in the first, we wanna know how much money in 14%, right? How about X dollars here, right? Yeah, we want to know how much money in the first box. We want to know how much money in the second box. How about Y dollars here? So we have 2 variables, right? Let's find the 2 equations. And together, Canon invests $7,600 in those 2 boxes. So that means X plus Y equals 7,600. We got one equation. We need to find another equation. Okay, how do we find the interest? So this is about simple interest for 1 year, all right? Simple interest for 1 year. The formula is very simple. Yeah, if you want to know more, look at your foundation 2. We have learned this formula. I equals P times R times T. I is the simple interest, P is the principal, R is the annual interest rate, T is time in year. Here we consider 1 year because it says at the end of the year. So for that reason, the interest is very easy to calculate. How do we do that? Look at the first box. The money, the amount of dollars is inside the box. The interest rate is on top of the box. Multiply them together. 14% times X. Multiply the interest rate above the box and the money inside the box. You will have the interest paid by that account for a year. Same thing. Second box, interest rate on top of the box. Amount of money inside the box. Multiply them together, give you the interest dollar over that year from the second box. Added together is the total interest Canon received over that year, $812. So the second equation is this one. Okay, second equation is this one. And you might want to do decimal instead of percent. Knowing percent means divided by 100. Per means divided by. Cent means 100. We have 100 cents in $1. Cent, right? We have 100 cents in $1. We have 100 years in a century. CNT means 100. So percent means divided by 100. Divide 14 by 100, 0.14x. Divide 2%, divide 2% means divide 2 by 100, 0.02 times y equals 812. So that's the second equation. That's the system we can use to model this situation. You solve it, okay? You solve it. This is a problem from Lumen. I get you the model and you practice solving it. Any question, guys?
No, you're explaining it well.
Okay, very good. Then we can do more problem. Yeah, this one application. A movie theater has a seating capacity of 397 people. Like you cannot, if they have 398 people come to cinema theater, then one person has no seat. The theater charges $5 for children, $7 for students, and $12 of adults. There are half as many adults as as there are children. Yeah, there are half as adults as there as children. In this English sentence just throw me off. There are half as many adults as there are children. There are half, we're going to talk about that later. If the total ticket sales was $2,878, how many children, students, and adults attended? Okay, we need to know how many children attended. Let's say X many. How many students attended? Y many. How many adults? Z. We need 3 formulas. We need 3 equations. Firstly, there are half as many, and if the total ticket sales was how many children, students, and adults attended, a movie theater has a seating capacity. It doesn't really say how many people in total attended the theater, right? We can only assume the movie theater was full. I think the question implies that. Otherwise, how do we use 397? I think it means the children, students, and adults, they just fill up the theater. So x plus y plus z equals 397. Equation 1. Equation 2, and I need help with this one. There are half as many adults as there are children. Adults is z. Children is x. There are half as many adults as there are children. Is this sentence saying number of children is twice of the number of adults, or number of adults is twice of number of children?
It's saying that there are twice as children than the adults. So if you find the amount of children, you have to divide it by 2 to find the amount of the adults.
So you are saying z equals 2x. That's what you're saying?
Z equals x divided by 2.
So you are saying x equals 2z.
Yes.
You are saying children, number of children is twice of number of adults.
Yeah.
Okay, there are half as many adults as there are children. There are half as many adults as there are children. Do we agree on that? You know, I actually in the TCC faculty Facebook group, a while ago I posted this English sentence. I asked the English professor, please help me. English is my second language. Could you help me to figure out which one is half of the other? And the English professor did not answer. Okay, so let's try that. Okay, let's try that. If you encounter this problem and you try this, it doesn't work, then you just switch the relationship. Do z equals 2x. There are half as many adults as there are children. Okay. Well, we need another equation. Let's see the money collected in total. $5 for children. So 5 times x, that's the money collected from children. $7 for students, 7y. That's the money collected from students. $12 from adults, so 12z. That's the money collected from the adults. Together, $2,878. Equation 3. All right. So we can eliminate variable x first because x equals 2z. You can plug in or substitute. Yeah, substitute 2z for x in equation 1 and 3. You will see variable variable x will be eliminated to read x. And then you will have a system with 2 variables only, and then you try again. Yeah, so I'm gonna leave the solving part to yourself. Yeah, we focus on the modeling part. This one is the next section. Well, we have 4 minutes. We have 4 minutes. Do you guys have any other questions? I can answer within the 4 minutes.
I don't.
You know, yes, please.
Sorry, I said I don't.
Oh, okay. You know what?
Yeah,
How about
I don't really have any questions either.
Okay, we have 3 or 4 minutes. Let's look at the Lumen together. I'm going to stop share the note and share the Lumen, share the web page. Are you able to see my Lumen?
Yes.
Okay.
Yes.
So let's go to 2.4. I want to talk about the graphing calculator. There's a way, or not, we do number 2.5 today, like that. 2.5 is what we do today. Let's see if you are able to use a calculator to get a problem done, all right? So this is a calculator. I never actually use it, but let's try. So this is a graphing calculator. If you enter the first equation, expression, you do 15x plus 3y equals 27. That's the first equation, right? Yeah. 15x plus 3y equals 27. And then you're going to do another equation is y equals -5x plus 9. That's the second equation. And look at what happened. Do you see the two equations, the two straight lines overlapping, coinciding? Huh?
Yes, I see.
Yes.
Yeah, you really could take advantage of the graphing calculator. Even I do not like it, but it's there for you to use. I would recommend you solve it first. Use what we learned today, and then use the graphing calculator to check. And on the test, I don't care which method you use. I just want you to get as high as possible score. And let's try this one is y. Let's see if we got it right earlier. -5x plus 9. It says if it has infinitely many solutions, write them in, oh, this one is in terms of x. So if it's in terms of x, okay, this is x, and this is -5x plus 9. So write y in terms of x. Yeah, that definitely is correct. Let me check. How do I check? It's correct. Yeah, it's correct. And yes, for example, this is an application problem. Yeah, for example, this problem, we use a calculator. The first equation, yeah, I actually do not like this because then you just use a calculator, even you don't know how, you still can't get it right. Equals -13. And the second equation is 1x minus 4y equals 17. Oh, no more, just to get rid of that one. Do you see that? Let's see if you can find a solution here. You can see there, oh, okay, they directly tell you the solution. You click the point here. No, this point. 1, -4. Don't click the wrong point, this one. 1, -4. One solution, which is 1, -4, closed parentheses. Check. Is correct. Well, I don't know. Then you don't have to learn the method. I think you should try to grasp the method and then use the graphing calculator